right? Anyway, so just remember the figures. Later with this more exercises, you will remember the values and you can then easily calculate this. So for an example, here you have to remember, so what is, so this is all the values, right? So starting from 2 to the power 0, 1, 2, 3, 4, 5, 6, up to 2 to the power 6 values are there. I'm going to add few more, and that is 4, 5, 6. Okay, these are the values. So it will be 16 and 32 and 64. So let's double the value. 2 to the power 0 is 1, and 2 to the power 1 is 2, 2 to the power 2 is 4, 3 is 8, 4 is 16, 5 is 32, 6 is 64. And the other hand, 2 to the power minus 1, 2, and you have up to 3. So I'm going to add minus 3 also. Oh, sorry. So should be added here. Minus 3 is 0.125. So it will be half. So here to the right side it will double, to the left side it will be half. And let's keep some gaps between these numbers and to identify them easily. Same here. These are the values. Now you have the numbers and the positional values. Now what you have to do, you have to multiply them, and let's point the values. Right here, 2 to the power 0 is pointing to this digit, 2 to the power 1 is pointing to the next digit. This is 2 to the power 1 that is pointing to the next digit. Okay, and then 2 to the power 2, it's not, it's 0, so no need to point that. So 2 to the power, this is 2 to the power 1, 2, 3, 4. 4 is, we can point that, sorry, 0, 1, 2, 3. 3 is pointing here because starting from the 0. 2 no need to point because its value is 0. And then you have 2 to the power 4, 5 not there, but 6 need to be pointed. So likewise this. And I'm going to, anyway, I'm going to color the values. This is, since this is your first example, let's color the value. This is red, and this is also red, and this is the value of that is also red, and this is, let's keep it in black color, all three in the black color. Next is, I'm going to change the value to blue color, and this is the digit in the blue color, and this is the digit in blue color, but value is 0, you can see. Then this is to the green color, and this is the bit value, positional value, and this is the value, and this is, again, I'm going to keep this in orange color, keep the same in orange, and this is the value. It's 0, no need to calculate that. And then again, I'll keep that in the black color, and this one I'm going to change the color to red color again, kind of orange. So let's make it red or purple. So this is the purple bit. Okay, now you have the decimal value. You have to take this one values only. 64 you have to add. Then to that you have to, no need to add 32, 16 no need to add because those are zeros. 8 you have to add. Then, or you can say 0 plus 0 likewise, right? Here also 0, you don't have value. This is 8 plus, and you have to add 4, you don't have value. 2 you have value, it's 2. 1 you have value, it's 1. And decimals, the same for decimals. Let me show the positional values. This is the positional value for first digit.
So this one you have so this thingy.
Sorry.
This thingy is there, right? This one.
Yes. This is sorry. It should be 16, right? So my
Yeah,
mistake. 16. This is because otherwise it's not valid.
yeah.
Right. Next. Let's insert this one. I'm going to do this in a perfect way in the first round, but in the second round or not, I'm going to summarize this time. This is 2 to the power 3. But for the other one, you don't have 2 to the power -2. You don't have. Okay, now you have to add, then the value will be 0.5 here. And the next one will be 0. And the next one will be 0.125. So I think you understood the concept. If anything difficult or if anything you couldn't understand, please let me know, then I can help. Did you understand the concept?
Yes, sir.
Okay. So what is the value then? 64 plus 8 is 72.
75.625.
Yeah, 72 plus 2 is 74, 75, 75.625. 75.625 is the value. So this is how the conversion is done. This is in decimal. You have to add
Which
all
one
the...
is?
Sorry?
We did everything, like we are in the third one.
All right. So the second one, just write the values, right? I'm going to write the values directly. 3 into, you have to tell the, okay, 3 into, so 8 into 8 into 8 is 25. Sorry, 8 to the power 0, 8 to the power 1, and 8 to the power 2. This is 64. Plus 8 to the power 1, that is 4, multiplied by 8 to the power 1 is 8, plus this is 5, multiplied by 8 to the power 1 is 1, plus 1 multiplied by 8 to the power -1 is 0.125. Then plus 2 multiplied by 1 divided by 64. Right, then you have to add the values. So what is the total? 64 into 3. Yes. 60 into 3 are 180.192 is the value there, and this is 32, and this is 5, and this is 0.125, and the last one is 0. Yes.
Which one? 0.125.
0.
No, which one?
2 multiplied by
0.03125.
0.03125.
3125, yeah.
1 divided by 32.
229.1562.
Right, 1 divided by 32, that you have to take by continuously dividing. So basically, if you 1 divided by 8 is 125, 1 divided by 16 will be 0.625, then again 0.3125 is the value. So let's add the values now. Decimal ones together, this is 5 plus 7, 7 plus 2, 9, 9 is the last digit, and then 3 plus 12, 12 plus nothing is there, so it's 2, and 1 plus is 2, 2 to 9 point, and this will be 1, then 4, 1, sorry, 1,
No,
4.
5. 15625.
Yes, 1. So this is 5, 2, this is 6, and this is 1, 5, 6, 2, 5 is the answer. 1, 5, 6, 2, 5 is the answer. This is 5, and you have to add, you can add 2 zeros there, right? Then you can easily add this. 5 plus 0 is 0, 2 plus 0 is 0, 2, 5 plus 0 is 5, 2 plus 0 is 2, then 5 plus 1 is 6, and 2 plus 3 is 5, 1 plus 0 is 1. Consecutive values you have to add. So the last one, it is right. A means this is 16 to the power 1, 16 to the power 0, 16 to the power 1, 16, 16 to the power 16 by 16, 256, 256 into 10 into 10. A means 10 plus, and 8 into 16 plus, and this E means 14, 14 into 1 plus 7 means 1 divided by 16. That 7 divided by 16 will be the value. And so the next one will be A means 10, 10 divided by 16, 16, 256 is the value. Okay, now you have to add the values. What is 256 into 10? 2560. 8 into 16. Yes. 128. Correct or wrong?
18 to 16, correct, sir. No, 512. No, 512. 512.
Is it 512?
Yes, sir.
No, 128, 128.
128.
18 to 16.
18 to 16. How come that? 16 into 10 even 160. 10 10 වැඩි කරත් 160.
So why do you take 256 into 10?
Yeah. Why, sir?
That one is wrong, right? Yeah, that one is wrong. That is, this is 16 into 16, no? 16 into 16
Yeah.
is
2048.
65,536.
This is 16 to the power 0, 16 to the power 1, and this is 16 to the power 2. Positional value is 16 to the power 2. 16 to the power 2 is what?
So then
Yes.
don't need to put that make the A as 10 and the 8 as 8 and the B as 14.
Yes.
No, sir,
So
select
side that you have to, you are thinking about the size. This is 10 into 256. Now are you
No,
okay?
sir, it's different, sir.
No, sir.
So what's the difference?
So should we take the
It must be
position?
2048.
So this is wrong.
Sir, you
then.
just try converting this.
Which one?
Sir, we converted first. We first converted this into binary and then into decimal.
No need. So you have the positional value. This is the positional value 16 to the power 0. What is the positional? If 16 to the power 0 is 1.
See, yeah, 1.
So then this is wrong.
16.
Which one?
No. We have done in different ways, just doing different ways. Sir, you do
We,
your way and so will. No.
No, your one
let's
should
study.
give the same answer.
Yeah. That's it. Yeah.
Your one should give the same answer.
Yes,
Yeah.
sir. Giving same answer. Yeah.
This is 16 to the power 0. Positional value is 16 to the power 0, which is 1. That is the method I have suggested. The particular number to the particular positional value. So this is the method I suggested. I didn't tell you, please convert to binary and then to this. No. So try to convert as original. There
no
are
need to put
shortcuts.
that A8E.74 as 10 as like this. No need to make like this.
No, that is no, that's not going to happen. So that is a single position. A is a single position, right? A is not two.
Okay.
Now
okay,
you have
sir.
taken this as two positions. Then it will be like it will be given big value than the expected.
Yeah, I got 67,604.411.
So here also the positional value is 8 to the power 0, 8 to the power 1, 8 to the power 2. Here 16 to the power 1, which is 1, and 16 to the power 0 is 1. 16 to the power 1 is 16, and 16 to the power 2 is 256. 10 into 256. Now only you take 10. 10 is the value, 10 into 256. 8 is the value, 8 into 16. Then E is the value. E is 14, 14 into 1. So you have to add 2560 plus 128 plus 14. And plus this 7 divided by 16. The value is, I'm going to calculate this 7 divided by 16. So it is 4375, 0.4375. And here 10 divided by 256. This is the value, right? So this part would be, that will be the difficult one, the finding out the decimal values, but the others will be easy. Okay, let's add the values. This one plus 0.4375 plus 14 plus 128 plus 2560, and that is, this is the value. So you should get the same value. If even though you write in the binary, you should get the same value. So let's do in the binary method, but that is not what I suggested. But since you have done that, I'll check that A means 1010, 8 means 1000, E means 1110, 7 means 0111, and A means 1010. This is in binary. Now you have to add the binary values. This is 0, nothing to add. 1 here, 2 to the power 1 means 2. 2 to the power 3, that means 4, and 8 will also be there. Then no 16s, 32 is not there, 64 is not there, 128s are there, that is 128. After 128, 256 not there, 512s, 512 is there, 512, 512 is there, and you don't have 1024, but you have 2048. And the other hand, so you have, so 0, it's 0.5 not there, but 0.125 is there, 0.125 is there, 0.0625 is there. Then the next one is, sorry, 0.25 is there, 0.25. This is 0.5. This is 0.25. 0.25 is there. Then the third one is 0.125, that is also there. Fourth one is 0.60625, that is also there. Fifth one is 0.03125, that is also there. Then the sixth one, you don't have any. Seventh one is 0. That is even half of this 0. Making bagigat 10 0.1. So making bagi, making not bagi. So likewise 0.03125. So half of that is this, and half of that is this. So this is the value. You won't get this much of decimals, right? You won't get this much of decimals, but I just tested the method only. Then 0.03125 plus 0.0625 plus 0.125 plus 0.25 plus 2 plus 4 plus 8 plus 128 plus 512 plus 2048. Okay, you can see the value. That is same. So even you use this method, you should get the same value. That's what I suggest. I told.
Okay, sir.
So what went wrong?
I combined this and the binary both instead of taking one.
Right. Okay. So whatever, this method also gives the same value, right? That is how you convert to the convert any number to decimal. You have to take the positional value, multiply by the digit value, and add it. Right? Take the positional value, multiply by the digit value, and add it. And this is the method suggested in the tut. Here tut suggested us take the positional value and find the digit value and multiply by that and add it, and that will give the answer. So here I think we have done several examples in the tut to find the positional values and add them up. Here this is how you convert binary to decimal. Binary to decimal, basically you have to add the positional values and add the numbers. That is easy, binary to decimal. Octal to decimal, so that is base 8 numbers. You have to find the base 8 digits and add it. And then hexadecimal, so you have to find then base 16 numbers and add it. Right, that is how conversion is done. Okay, let's see the other way, how to convert a number to other number systems. So that is the second thing that we have to look at. Okay, write the question. Convert the following decimal number to convert the following decimal number to binary, octal, and hexadecimal. Binary, octal, and hexadecimal. Convert the following number to, so please write down the question, convert the following number to binary, octal, and hexadecimal. Okay. Let's take example, and the remaining part I'll give you as a homework. So let's take one example and then we can understand the other. So let's say 56, let's say this integer number without a decimal number. Let's take integer number 56 in decimal. How we are going to convert this to the other number systems? So simple. So you have to divide by base continuously and write the remainder. Method divide by the base and write the remainder. Then read remainders left to right or bottom to top. So that is the method. Okay. So rather than writing like this, so let's use and let's do this and understand. Maybe otherwise you won't understand, but if you do this, you will understand, right? So let's say the number is 56. මම table එකක් ගන්න අර බෙදීම mark කරන්න ලේසි වෙන්නේ. Let's say I'm taking a table. So what I'm going to do is I'm going to remove the top border from the table. I'm going to remove the top border. I don't need this. And I'm going to remove the right border also. Top border and right border I'm going to remove. And this is also not needed. I'm going to remove these borders also. Oh, how to keep the other side. Okay, now you can divide by 2. That's why I have taken this structure. 56 divided by 2. What is the answer? 56 divided by 2? 20. They can be down here. 56 divided by 2.
28.
28. And the remainder is 0. Nothing remaining. Remainder is 0. Then next one. 28 divided by 2. It's 14. And remainder is 0. Then 14 divided by 2. It's 7. And remainder is 0. It is again you have to divide that by 2. Then you will get 3, but remainder will be 1 because 7 you can't divide sharply. Then that 3 divided by 2 is going to the next line. 3 divided by 2, 1, and remainder is also 1. Then you have to take bottom to top, all F2. So this is how
I can put 2 and 0 and then 1, right?
Yeah, that is also possible. That is also possible, but no need that because all the digits are now in binary, no, so no need to further divide. Therefore, no need to further divide because all the digits are now in binary, so we don't need the further division. That's right. So you can now write the number, and that is none other than write the number over there. It is 111000 in binary. That is how the conversion happens. Okay. So what about the other one? What about the other one? That means octal and hexa. Do the same. Or write tree by tree. That short method is there. But for the moment, you try the normal method, right? For the moment, don't follow this. Anyway, this is 70 in octal. You know that because 111 is 7, 000 is 0. So just by looking at, you can write the number in octal, but follow the method. So 8. 56 divided by 8 is 7, remainder 0. No need to divide further because now you have done the thing, right? No need to divide further because already all the digits are now in octal.
Then 87.
Sorry? No, it's 70. You have to take from here to here. Here to here.
Okay.
Value is 70. So even by dividing, you'll get 70 in octal. Hexadecimal 1. 56 divided by 60.
7, 0.
7 remainder 0.
Yeah.
Okay. So this one, can you tell me the answer? 56 divided by
3.5 is done. So
don't tell points. So
yeah.
3 remainder. 3 remainder.
1 minute.
3 is 48. Then remaining
8.
8. Yes, 3 remainder 8. And you know the short method is also supporting this, right? In short method, you will write 4 by 4. When you write 4 by 4, you can see here in beginning zeros, it's 3, 8. 3, 8 is the number. So, but no need to take that. So let's go for the traditional method. Traditional method also says 3 remainder 8, and that is 38 in hexa. Okay, so that is how you are going to divide these numbers. Right, now just give a try to convert these numbers as a homework.
So could you go up? Then I'll just take a screenshot of this.
Okay. Right, let's plan to finish the lesson, this number system lesson at least by next week. So these easy lessons, we have to make it faster, right? But I need your support. So do the homework and come.
Okay.
Right, because you have to speed up. Even though the lesson is easy, the methods are easy. So practicing is must. If you cannot practice, you will not develop your speed. So
Yes,
the main concern for these questions is the speed. It answers you can get, but speed is really important. Okay, so let's say homework, and so what you have to do is convert these numbers. Convert to binary, octal, and hexa. Okay, these are the questions. The first one, second one, third
Convert to
one.
convert, right?
Convert to binary. The second one, 8192. Third one, 4 fourth one. And the fifth one. That's one thing to think, right? This decimal part you have to think, because I have not explained how to do that, but just try, just give a try. Okay, this part you have to do as a homework.
Okay, sir.
Right, okay, with that I'm going to stop for today. Do you have any questions up to this, other than these two? These two you have to think. Other than these two, any other difficult area or unclear area?
Nope. No.
Okay, so please remember the method. Don't do that the previous one that you have done. When you are converting the hexadecimal is critical. So just follow the method. Don't convert before getting the value. Don't write 10 over there. Then you will treat that as a 2-digit. This A is single position. But if you write 1 0 like 10, then that is 2 positions. So don't write A. After getting the value only, you multiply by 10.
Okay, sir.
Right, okay. So then let's stop for today and see you all next week. Okay, have a nice day. Bye.
Bye.
Yeah, thank you.